All right, so I do hope that there is no lagging within the video, and I hope that what we're about to do makes a whole lot more sense. So the point of dimensional analysis is all about converting units. Units are there to tell you how much of something is present. So when I give you the example of when does 0.5 minus 60 equal 11, in a general sense of what we understand from math, that statement should never be true. But if we add units, then that problem could be true. So it all depends on units. This particular example is going to be based off of time. If you look at time, we have 24 hours in a day. So half a day is going to be 12 hours. So I'm just going to write day here. We have exactly 60 minutes in an hour. So this is going to be MIN as an abbreviation for minutes. So half a day minus 60 minutes would equal 11 hours. So HOUR. And please forgive me, I'm trying to write this using a touchpad. So a half a day minus 60 minutes equals 11 hours. So if I pull up or extend my explanation here, you see that half a day is equal to 12 hours, 60 minutes is equal to 1 hour. So essentially the math problem is saying 12 hours minus 1 hour equals 11. So units matter. When we have units, they will generally be for mass, how much something weighs. You will have volume, that's how much space something takes up, whether it be a liquid or air. That's in liters, milliliters, or centimeters cubed. You have temperature, which is generally measured in Fahrenheit or Celsius. Later this year, we'll learn about Kelvin. There's also length, centimeters, kilometers, inches, meters. Anything in that regard is going to be a unit of measurement. So if we go to our second slide here, all units have to be equal to something. So 100 pennies is equal to $1. 10 dimes is also equal to $1. Our most common form that we like, 4 quarters, is also equal to $1. Now, I'll be honest, I'd much rather carry around those 4 quarters than 100 pennies. But regardless, 100 pennies or 4 quarters, they both equal the same thing. They both equal $1. So in order to convert something, it has to have something else that it's equal to. Our currency, for example, the US dollar and the Mexican peso are worth two different things, worth two different values. However, they're based on a gold standard, which gives us a conversion factor. If we're going to look at length, we have 100 centimeters being equal to 1 meter. If you're going to look at inches, we know that 1 inch is equal to 1 inch is equal to 2.54 centimeters. That's a conversion factor. That's a fact. It never changes. So what we're going to do next is go here to our document camera, because we had two problems, and both of them were dealing with the metric system. The metric system is based on tens. And we're looking at King Henry died by drinking chocolate milk. That's an easy way to kind of remember our metric system. King is going to stand for kilo. H is going to stand for hecta. And our D here is going to stand for deca. B is our base unit. That'll either be grams or liters or meters. And that will be your base unit. On this side here, on the right side, D will stand for deci, centi, or milli. Your right side is generally your smaller units. The left side is generally your larger unit. So if we're going to look at the first example, this is going to be on slide 3. Our first example was converting 4.76 kilometers to meters. How would we do that? Well, this goes back to the metric line that we had just written, KHDBDCM. Our dead giveaway when we're dealing with metric units, our last letter is generally our base. So this is telling me that my base is going to be in meters. The first letter is going to tell me how big or how small it is. So as you see, we're dealing with K, so that means we're going to be looking at kilo. So we're going to go from kilometers to meters. How do we do this? Remember, this is a base 10 line, so that means we can simply move the decimal. If we're dealing with kilometers, we will simply move the decimal 1, 2, 3 times to the right in order to get to meters. So what does this mean when we're looking at the number? Well, we moved the decimal 3 times to the right, so that's what we're going to do here. Move the decimal 1, 2, 3 times to the right. Your missing area here will always be filled with a 0. So that means 4.76 kilometers will be equal to 4,760 meters. Going on to our second example. If we have 1,800 milliliters and we're needing to go to liters, again, we're looking right here. This is our base. This is where we're starting. So we're looking at milli. I'm going to write a separate metric line. So K, H, D, B, D, C, M. So my base is going to be liters. And I'm starting with my milli. So that means I'm looking right here. Now, some of y'all may look at this and say, okay, I understand the number and I understand that we're doing something with a decimal. And you're going to be looking right here to the number. And some of y'all may turn around and say, there's no decimal, how can I move the decimal? Well, let me remind you of something from back in elementary school. If you have a whole number, it is automatically assumed that the decimal goes at the end of the number if one is not present. So that means your decimal for 1,800 goes right here at the end. Okay, so now we know that we're starting here at milli, and we have a decimal, and we need to go to liters. What you'll do is you'll move 1, 2, 3 times to the left to get back to your base. So in order to convert between milliliters and liters, you will move that decimal 1, 2, 3 times to the left. 1, 2, 3. That means you have 1.8 liters. So this was about how far I was wanting to get in the lecture today. Please remember, if you are asking a question, you have to be specific. If you email me and say, I don't understand, I can't help you because I can't read your mind. Which part of this is not being understood? Is it moving the decimal, the number line? Is it looking at the basic metric system? And don't tell me all of it either, because that doesn't give me a place to start. So if you do have questions, I encourage you to email me or even use the Remind app to send me a message that way. But please remember, when you ask questions, please be specific so that way I can help you to the best of my ability. Other than that, thank you for telling me that there were issues. And we may, if there's continuing to be lagging issues, we may have to watch the lecture video before coming to the class. That way we can do homework or classwork together. So I do hope that you'll have a good evening, and I will see y'all in class. Let's see, today is Wednesday, so I'll see you again in class on Friday afternoon.